Hello students, I hope that you are good, well and fine. In today's session, we will be seeing product of two vectors. Okay. So far what we have seen addition and subtraction of vectors, product of a vector by a scalar. Yes, we have seen triangle law. We have seen how to find your addition or sum of two vectors by using parallelogram or parallelogram law and all of these things. Okay, now we also saw the product of a vector by a scalar. Now we will be seeing how to product, or what are the different types of a product we have defined when we are going to product two vectors. Okay, so let's see. First one is scalar product or dot product. Okay, we will be seeing about dot product, how we define it, what is dot product. We'll see some properties. Okay, and how to use, when it will be used, all we will be seeing in this session. So definition: scalar product of two non-zero vector. So first of all, you are having two non-zero vectors a and b, denoted by the scalar vector. I am talking about scalar vector denoted by vector a dot vector b. As you can see, that's why we say it as a dot product or scalar product, defined as a vector a dot vector b is equals to magnitude of a multiply magnitude of b multiply cos theta, where theta is angle between vector a and b, and this theta must be from where to where? This theta must be from 0 to pi. Clear? Okay. If either a is 0 or b is 0, then it is not defined. Okay. Then if either a is 0 and b is 0, then theta is not defined. Clear? Okay. And in this case, we have what? We have this, that a dot b is equals to 0. A dot b is equals to 0. Clear? I hope it is clear to you. Okay, the visual representation is like this, that this is your a vector direction, this is your b vector direction, and in between you are having an angle theta. Okay, now some observations: that vector a product dot product vector b is a real number. The output must be a real number. Why I am saying that? As you can see, this is magnitude, and magnitude will always be some real number. Okay, this is cos theta, where theta belongs to this interval, and in this interval cos output will give you what? Real value. So that's why the whole thing which is dot product will be some real thing. That's why it is written over here. Let vector a and vector b be two non-zero vectors. Then vector a dot vector b is equals to 0 if and only if a and b are what? Perpendicular to each other. Okay, a and b are what? Perpendicular to each other. This means that a dot b is equals to 0 if and only if a is perpendicular to b. Okay, a is perpendicular to b. Clear? Okay, now if theta is 0, in this particular case, a dot b will be what? Magnitude of a multiply magnitude of b cos theta. Cos 0 will be just 1. Okay, in particular a dot B in particular, A dot A will be what? Magnitude of A square of magnitude of A, as theta in this case is 0. Okay. Now if theta is pi, then dot product of AB will be negative of magnitude of A and B. Okay. In this particular case, you will have dot product of A and B is equals to minus of magnitude of A multiply magnitude of B, as theta in this case is pi. Okay. Now observe 2 and 3 for mutually perpendicular unit vectors. So you will have I dot I is equals to J dot J is equals to K dot K is equals to what? 1. Why? As I, this vector and this vector makes an angle 0 degree. Yes, so that's why it will be the magnitude square of the magnitude of these vectors. Okay, and the magnitude for this vector will be what? As you can see, this third point, you will get 1. In this case, I dot J, J dot K and K dot I will be 0. Why? As they are perpendicular, already written over here. When you have two vectors perpendicular to each other, their product will be 0. Their product will be 0. Okay, I hope it is clear. Okay. So clear? Okay, now what we are having now, this means that the sixth property says, or observation, the angle between two non-zero vectors, A and B is given by cos theta is equals to dot product of AB divided by product of their magnitudes, or in other words, theta will be cos inverse dot product of AB divided by the product of their magnitudes, as you can see. Okay, so in this way you can easily find your theta, and always remember that theta belongs to from where to where? Closed interval 0 to pi. Okay, now scalar product is commutative, that is A dot product B is same as B dot product A. Okay, clear? Now, two more interesting properties of scalar product. Property 1 of distributive property of scalar product over addition. When you have three vectors A, B, C, then A dot product B plus C is same as A dot product B plus A dot product C. Okay, now second property says, when you have two vectors and one be any scalar, okay, sorry, lambda, here it must be lambda be any scalar, this is not 1, it must be lambda be any scalar, then lambda A product with vector B is same as what? Lambda product with A dot B, or A dot product B, or in other words, A dot product with lambda B. Okay, all are same things. Clear? Now what we are trying to show, when you have two vectors A, B, and their component form is given to you, this is A1 I hat plus A2 J hat plus A3 K hat, B1 I hat B2 J hat plus B3 K hat. Then their scalar product is given as, so in this specific way we are defining our scalar product when component form is given. So how? Let's see that this, so using the distributive property, this must be going to multiply with this, A2 must be going to multiply with this term, and A3 k hat going to multiply with this term, as you can see here. Now this going to multiply with this term, this going to multiply with this term, this going to be multiplied with this term, and the same goes for the other terms also. Then you will get this as your expansion. Then what? You just already saw that I dot product I will be just 1, but I dot product j and I dot product k will be what? 0. Yes, the same goes for j dot product I and j dot product k, and same goes for k dot product I, k dot product j. Okay, using properties 1 and 2, you will get a1 b1, a2 b2 and a3 b3. Okay, so if you are having two non-zero vectors, then then their dot product is defined like this, that just multiply your x component to the corresponding x component of the other vector, the y component to the y component, and z component to the z component, and add them. You will get your dot product. This is what already written over here. Okay, I hope it is clear. Now projection of a vector on a line. So suppose vector AB makes an angle theta with a given directed line L in the anti-clockwise direction. Okay, so you are having AB vector making theta angle, okay, with a given directed line, okay, in the anti-clockwise direction. Clear? So as you can see, your AB vector, prefer this figure, okay, your AB vector, your line, okay, and the angle between your vector and the line L in anti-clockwise direction will be theta. Another way of representation like this: AB vector, your line L, anti-clockwise angle, AB vector, your line L, anti-clockwise angle, AB vector, your line L, your anti-clockwise angle. Okay, now in first case, as you can see, the theta must be from 0 to 90. In second case, 90 to 180. In third case, 180 to 270, and in fourth case, 270 to 360. Okay, we have taken 4 different cases to understand the projection or this relation. Then the projection of AB on line L is a vector P. So when we talk about projection, this means it must be what? A vector P. So this projection must be of in the form of vector. Okay, so P vector we are saying, with magnitude what? The magnitude will be what? The magnitude of AB vector multiply with absolute value of cos theta, the angle between theta, where theta will be the anti-clockwise angle between the vector and the line, and the direction of P, vector P, being the same or opposite to that of the line. It's depend on theta is positive or negative. Whether cos theta is positive or negative. Okay, clear? As you can see, these possible cases. Okay, so we will be calling P as your projection vector, and its magnitude will be magnitude P. Okay, magnitude or absolute value of P. Clear? Which we have defined like this, simply called as the projection vector of the vector AB on the directed line L. Clear? For example, if you try to see in each of the following figures above 1 to 4, projection vector of AB along the line L is vector AC. As you can see, the projection vector is this AC. As you can see, this P, this AC P. this AC, this AC. Okay, as you can see, the direction is here, the direction is same as the direction of the line. Here the opposite direction, the same direction. Okay. Okay, now let us move next. Some observation. If vector P is the unit vector along a line L, then the projection of a vector A on the line L is given by A dot P vector. Sorry, yes, unit vector P. Okay, clear? So whenever you are having P as your unit vector along a line L, then the projection of a vector A on the line L is given by dot product of vector A and unit vector P. Clear? Okay, now projection of a vector A on the other vector B is given by dot product of vector A with unit vector of B. Okay, and this unit vector of B can be rewritten as B divided by magnitude of P. So the other form for this. Okay, clear? Now if theta is 0, then your projection vector of AB will be AB itself, and if theta is pi, then the projection vector of AB will be BA. Okay, just the negative, the direction will be the negative, that's it. If theta is equals to 90 or pi by 2, 90 degree or pi by 2, or 3 pi by 2 or 270 degree, then the projection vector of AB will be 0 vector. Clear? Okay. If alpha, beta, gamma are the direction angles of vector A, direction angles, this means what? Okay, this means that your direction cosines will be cos alpha is equals to A1 divided by what? Magnitude of A. Cos beta will be A2 divided by magnitude of A. Cos gamma will be A3 divided by magnitude of A. Okay, we have already defined it. Also note that you can, after rearrangement, you will get that this x component or this will be what? Magnitude of A times cos alpha. Y component will be magnitude of A cos beta, and z component will be magnitude of A times cos gamma. Okay, and they are the respectively the projections of A along OX, OY and OZ. That is, the scalar component A1, A2, A3 of the vector A are precisely the projection of vector A along x-axis, y-axis and z-axis respectively. Further, if A is a unit vector, then it may be expressed in terms of its direction cosines as vector A is equals to cos alpha I hat plus cos beta j hat plus cos gamma k hat. Okay, clear? Okay, now let's see some examples so that you will have some clear idea what we have just saw. So find the angle between two vectors if their magnitudes 1 and 2 are already given to you, where 1 is the magnitude for vector A and 2 is the magnitude for vector B. Okay, and another information is already given to you that their scalar product or dot product is equals to 1. We have already defined our dot product must be what? That cos theta must be A dot B divided by magnitude of A and P. Or in other words, theta will be cos inverse dot product of AB and product of their magnitudes, as you can see. So A and B both, the product is 1, so 1. Denominator will be 2. So cos inverse half will be pi by 3. So you will have your theta as pi by 3. Simple. Now find angle theta between these two vectors. So you have A, you have B. Cos theta will be what? A dot B, the scalar product of AB divided by the product of their magnitude. A dot B, as you can directly see, that X component going to multiply with X component, Y component going to multiply with Y component, Z component going to multiply with Z component. You will have 1 minus 1 minus 1. This means just numerator will be just minus 1 and denominator will be the magnitude of A and magnitude of B. So you will have magnitude of A will be same as magnitude of B, which is root 3. This means root 3 square. This means just root 3. So cos theta will be minus 1 by 3. Hence your angle will be theta is equals to cos inverse minus 1 by 3. Yes, so you will have this as your required angle. Now another example. If vector A and vector B are already given to you, then show that their sum and their difference are perpendicular to each other. This means we have to show that first of all find the sum, as you can see, sum, and then their difference, and then find the dot product. If you find dot product is equals to what? 0, then it will imply that they must be perpendicular to each other. So A plus B is 6i hat plus 2j hat minus 8k hat. A minus B is equals to 4i hat minus 4j hat plus 2k hat. Their dot product will be just multiply 6 with 4, you will have 24. 2 with minus 4, minus 8. Minus 8 with 2, minus 16. As you solve it, you will get 0. This means both will be perpendicular to each other. Okay. Next example. Find the projection of vector A on vector B. So you have to find the projection of vector A on vector B, another vector. So very easy to find. Whenever you have to find a projection of a vector on some other vector, you have to do what? Apply your concept. What concept? That dot product of AB divided by magnitude of B. Okay. So dot product of AB divided by magnitude of B. So dot product of AB will be what? This will be dot product or scalar product. Why we said that it is scalar? Because their output always be some numerical value, as you can see. Yes, in dot product, the other name, or it is also goes by the name of scalar product. Why we are gave such name scalar product? Because their output is some scalar thing. Okay. Now dot product for AB will be 2, 6 and 2. Add them, you will have what? 2, 6, 2 means 10. So 10, numerator will be 10 and denominator will be magnitude of B, and magnitude of B will be what? Root 6, as you can see. So 5 by 3 root 6. Okay. Clear? Okay. So your projection of vector A on vector B will be this. Now, next example, that magnitude of difference of A and B, these two vectors, you have to find. If two vectors follows these conditions, that magnitude of A is equals to 2, magnitude of B is equals to 3, and dot product must be 4. Okay. You have to find this. This means magnitude of A minus B whole square will be same as dot product of A minus B with itself. We have already seen such criteria. Now distribute it. You will get dot product of A with itself minus dot product of A and B minus dot product of B and A plus dot product of B with itself. This will be magnitude of A whole square. This will be magnitude of B whole square, and this will be reduced to, as a dot product is commutative, this means minus 2 times of dot product of AB. You know the magnitude of A, you know the magnitude of B, you know the dot product. You can easily substitute your value and solve it. You will get your answer for A minus B modulus whole square. Okay, and apply the root, you will get your final answer. This will be 4, this will be 8, so minus 8 here, this will be 9, so just 1, you will have 1, apply root, both side you will have modulus a minus b as your plus minus 1. Okay. Clear? Now next example, if a vector is a unit vector and follows this condition, then find magnitude of x vector. Since a is a unit vector, so this magnitude of a will be just 1. Now what you have to do is, first of all, write this, then multiply them or distribute them. You will have vector x multiply with x, dot product of x and a, dot product of a and x, dot product of a and a. This will be square of magnitude of x, this will be square of magnitude of a, this will be just cancel. You will have square of magnitude of x minus 1 is equals to 8. This means square of magnitude of x is equals to 9. This means x will be 3. This means x will be 3. Clear? I hope it is clear to you. Now next example. For any two vectors a and b, we always have this inequality. Okay, and this inequality we will be calling it as Cauchy-Schwarz inequality. Okay, so Cauchy-Schwarz inequality. Clear? Let us show it. So the dot product. So first of all, if either a or b is 0 vector, then you have already seen that we have already defined, we cannot, first of all, theta cannot be defined here, and the dot product we have defined is equals to 0. This means dot product, absolute value of dot product is also 0. This means magnitude of a and b both and their product will also be 0. So both equal to each other. Okay, so this is when either of them is 0, this means both must be equal. As you can see here, we have used equality in our inequality. Okay, at this stage, if either of them is 0, then you can say that both must be same as 0. Now assume that none of the given vectors are 0, then you can easily find their dot product, their magnitude, and also you can easily divide your magnitude, divide by the product of their magnitudes. As you can see, magnitude of a multiply with magnitude of b, which is same as what? This is same as what? Cos theta. You all know that this is same as cos theta, and cos theta magnitude will be less than equal to 1. You all know that. Yes. Okay, this means just cross multiply, you will get your this inequality. I hope that this inequality is now clear to you. Okay. Clear? Now next example, for any two vectors a and b, we always have absolute value of sum of a and b vector is less than magnitude of a plus magnitude of b. This is triangle inequality. Okay, now what? The inequality holds trivially in the case either a is 0 or b is 0. If either a is 0, b is 0, you can see this will be either of these two terms will be vanished, and here also the vector, one of the vector is going to be vanished, so you will have the equality. Okay, now we will be assuming that none of them are 0 vectors. So this means if vector a is not 0 and vector b is not 0 vector, then their magnitude will also be non-zero. Okay, then the square of the magnitude of a plus b will be same as dot product of a plus b with itself. Now use the distributive property. You will have dot product of A and A, dot product of AB, dot product of BA, dot product of B with B. This is just square of absolute value of A. This is square of magnitude of B, and because scalar product is commutative, you can write it as 2 times A dot B. Now, what do you know? That this dot product is less than the magnitude of A dot B. Okay, this gives you, and this is, you can rewrite it as less than, we have already seen this, that magnitude of dot product of AB can be less than or equal to magnitude of A multiply magnitude of B, Cauchy-Squartz inequality. So you will have this, and this is just nothing but magnitude of A plus magnitude of B whole square. Yes, and as you know that both side having square, so you apply root, you will get your inequality as length or magnitude of A plus B vector is less than equal to magnitude of A plus magnitude of B. Okay, so this is it in this session. I hope that you understood the concept, you understood the projection of a vector on another vector or on line also. Okay, so this is it for now. We will be back with exercise 10.3 related to this concept of projection, concept of dot product, and their observations, their properties. Okay, so thank you all.